guys, I want to review just some different forms of numbers that we're going to be working with in this next module. This is our last module before we take a big Unit 1 test. So we really just want to make sure that we kind of have this foundation and then we can move on. So one of the things that they want us to do in this module, and it's really important, is we want to be able to get all of our numbers in the same format. So different formats that we have, and you can label these notes today just rational numbers. Rational numbers. Okay, so we have mixed numbers, and I know that you've worked I promised I could spell. I know that you've worked a lot with these. They look something like this. Okay, and it's considered mixed because we have a whole number in front and we have a fraction behind it. And while this might make sense in some examples, maybe if we were cooking, okay, we would need a mixed number. In math, we don't use these very often from here on out. So even though you're very used to seeing these, we want to undo this every single time. And I think a lot of you saw that with the problem of the month. We don't want mixed numbers. We want what's called an improper fraction. And I know it's a horrible name for it. I don't know who came up. I would love to talk to the person who came up with the name for that. Improper fraction. Remember, if I write, you write. Okay, even though it says improper and it makes it sound like it's something we don't want to use, like I said, I wish I could talk to who made that name. Improper fractions are actually what we want to use almost every single time in math. It is a good first step to turn every mixed number into an improper fraction. And when you're in algebra, you're going to want to leave it in an improper fraction format and use it, okay? It's going to make your math so much easier. And we'll talk more about that before the year is over. I have a lot of strategies for how we can work with fractions. And all my strategies, you have to have an improper fraction. So I'm going to remind you or teach you, it's okay if you don't remember or never have learned this, how to turn this mixed number into an improper fraction. Okay, so what you do, and honestly, I would use a calculator for some of this math because I'm grabbing my calculator. Double check your simple multiplication. And you see, even with me, I make multiplication mistakes. I make division mistakes. I understand the concept, and my brain is working so hard at doing a really complex problem that sometimes in the middle of the problem, I do some multiplication wrong. So on problems like this, have a calculator to at least check your work. So maybe get used to practicing it on the side. What I do is I'll do my math kind of on the side and then bring my math back into the problem and then check it. Check it with your calculator. Make sure that you didn't make a simple multiplication error, okay? So what we do is we do 3 times 4. I know I'm going to use the x, even though we don't normally use the x, but we're going to do 3 times 4, and then we're going to add the numerator, and we're going to keep the denominator. And what I mean by that is my answer is going to have 4 as a denominator still because it had 4 as a denominator here, okay? So 3 times 4 is 12, plus 3 is 15. And this number, this improper fraction right here, means 3 3/4. And it allows us to do a whole bunch of things with it that we couldn't do if it was in 3 3/4. Okay? So to take it one step further and have a decimal, which sometimes you want to do and sometimes you don't, and you're going to have to kind of make that decision for each problem. But to take it one step further and make it a decimal, we can take, so here's our last form, we can take the 15 and divide it by 4. Okay? Now, you can work that out. Like I said, sometimes I like to do my math kind of on the side. Okay, so 4 goes into 15 3 times 12. Bring down your 3, bring down a 0. 4 times 7 is 28. 2 0, and 4 goes into that 5 times. Okay, so our decimal, and if you do this in the calculator, just know the top number in your fraction goes in the calculator first, no matter if it's bigger or if it's smaller. Okay, top number first. So 3.75 is the actual number that we are working with. And please understand, 3.75, 15 over 4, and 3 3/4 all mean the same exact thing. And if you can make some connections here, it's going to be a little bit easier. 3/4 is 0.75. So this is 3 3/4. 3 and 0.75. Okay, so that is how you work from a mixed number to an improper fraction and down to a decimal. We're going to be looking at a lot of numbers in this module. And some of it you're going to have to classify. That means tell me the name of it. Is it rational? Is it natural? Is it whole? Is it an integer? Some of it you're going to be ordering the numbers, and it's going to be really difficult to order your numbers if you don't have them all in the same format. So by putting them all into decimals, it really helps us get that on a number line. Because if you told me to graph 15 over 4 on a number line, I'm going to be really confused where not just you, me, I'm going to be confused where it is. I have to see it as the 3.75 to go, oh, this is a number between 3 and 4, and it's close to 4. Okay, so you really want to make sure that when you're classifying or you're ordering or you're comparing, you have everything in the same format, and I'm saying you should go with decimals. Okay? So that being said, I'm going to erase, pause it if you haven't written everything. That being said, let's just remember a couple simple things about comparing numbers. So if I write, you write. Closer and see. Okay, so just this is really a review, but it's okay if you didn't know this, so just pay attention, please. Couple things about these numbers. First of all, I don't normally put the zeros, but you could put a 0 here. It does not change the answer. So that means a 0 can go here, a 0 can go here. Okay, but just know a lot of people are not putting the 0. They're starting with the point, and we know there'd be a 0 on this side. So I really want you to get used to it both ways, okay? So when we're comparing numbers, we start with the number in front. So let's look at A. 8 and 8, same number. So we go to the next spot. 8 and 6. Well, 8 is bigger, so I open up my sign to the bigger number. Remember, this is a small side. This is a big side. So this is pointing to the small number, and this is opening to the big number. Okay? And you can see if these were, 10 over 4 compared to 8.86, we'd have a really hard time deciding which one was bigger. That's why we want to go with decimals. Okay? So let's look at this one. The zeros do not count. That's why I'm allowed to leave them off when I write the numbers. Okay? And I know that confuses some students, so I want to make that really clear. But the zeros don't count. So we're going to start at the decimals because there is a 0 in front of both. Right after the decimal is a 7. Okay, so that's not helping us. Now, I already know some of you are going to go, okay, well, this number has more numbers, so it must be bigger. You can't do that. You have to go one place at a time. So I compared my 7s. Now I compare the 3 and the 5, and the 5 is bigger. So I open my sign up to the 0.75. And think about it, 0.75 is bigger than 0.32. This last 2 doesn't really change anything. We only needed that 2 if this number had another number at the end. Okay, so this one, so we start at the decimal because there's no number in front, and we move to our second number. Now, 2 is bigger than 0, so we're done. That's the bigger number. Okay, don't be fooled. Look what they did. They threw a little extra 0 in there. hoping you'd see the 22 and the 22 and think that they were the same, but they're not. You have to go one place at a time. Okay? So hopefully that was a good review, or you learned some things and you're going to need that for this next section. Okay? Thank you for watching.